So example 3 has a lot going on here. We have an absolute value in the denominator, and looks like we have common factors as well that might cancel out. So first thing is that we have restrictions at x equals plus minus 1. Now, what's going to be happening at those different restrictions are going to be different. So let's take a look at the domain first. The domain is when the inside here is equal to 0, or where those are the boundaries, and where it's above 0, it's going to be the positive domain. Where that function is below 0, it's going to be the negative domain. So we have that function here. I've just graphed the inside to help me out with the domain. So when I take a look at that parabola, x squared minus 1, it is a parabola with a vertex at -1s and zeros at 1 and 1, -1. So we know that on the left of -1, it's positive. On the right of +1, it's positive. So my domain then, we can establish, is going to be looking like this. So the left of -1 and to the right of +1. That's my positive domain. Now, when I establish my positive domain, what ends up happening is I'm going to use the positive version of this inside function. So I don't change it at all. But what I've done is I've factored it. Okay. And the reason I factored is because there are common factors, and we can see that there's going to be an x plus 1 factor that's going to cancel out. And that's actually going to give us a whole. Okay, so there's going to be a whole at x equals -1. And it's because of this canceling that occurs here, we get this whole. So looking at the negative domain, it's going to be negative domain between -1 and +1. So that establishes my negative domain. Okay, so I get my negative domain here, all between -1 and 1. And when I do that, when I take away the absolute value with the negatives, the negative domain, I have to make sure that I switch the sign. And I put the sign on the numerator. Okay, so I factored it, and I put the sign on the numerator. And again, in the negative domain, we can see we have common factors, and we're going to cancel those out, and we're going to again establish a whole. Now, the thing about this whole is that because of the way the functions are defined, so it's defined at the -1, so that we have a whole at -1, and we have a boundary at -1. As I approach the whole from the negative side, I'm going to have to use the green function. And as I approach the whole from the negative side, because that's the x is less than -1, I'm going to use the green function. And since the negative domain gives us x is bigger than -1, I'm going to approach the -1 from the positive side. When I do that, I need to use the red function, because that's the function that's defined on the positive side of -1. So when I analyze the whole here, we're going to end up with two different limits, because I'm going to simplify this. So when I cancel those out for that whole, I get x over x minus 1. So there's going to be a vertical asymptote at -1 here. And on this one, I'm going to get negative x over x minus 1. And again, there's going to be a vertical asymptote in there. So at +1, okay, that vertical asymptote is going to be we're going to approach that vertical asymptote using those different functions as well. So looking at the limit as x goes to that whole, we're going to deal with the whole first. So as x goes to that whole from the negative side, I'm going to be using the negative domain, the positive domain function, or the green function, because that approaches it from this side. So I've drawn it on here. That's going to be approaching the graph, the -1 from that side. The negative domain is going to be from the right-hand side. So I'm going to approach the -1 from this side using the red function. And when I do that, when I plug in -1 into the green function, I get -1 in the numerator. -1 minus 1 gives me -2 in the denominator. And that gives me the limit of +1/2. So as I approach from the left-hand side, it's going to hit the +1/2 value here. As I approach it from the right-hand side, I'm going to use a red function. So I'm going to end up with negative of -1 when I plug the -1 limit in. And in the denominator, I get -1 minus 1 is -2. Well, that's positive over negative. So that's going to give us -1/2 as my limit. So as I approach from the right-hand side in red, I get -1/2 as my limit. So I get two different limits. So it's a discontinuity at that point. Okay, so at the boundary point of the domain restrictions, we end up with a discontinuity. So that's the issue of the hole. We have a discontinuity at the hole because the left-hand limit and the right-hand limit are different when we use those two different functions. So I put those coordinates in the table of values here. The other part of the denominator is a vertical asymptote. So in both cases, we have a vertical asymptote and the boundary is at 1. So that vertical asymptote happens to be a boundary between the red and the green parts of the function. And it is a vertical asymptote because we're dividing by 0 there. So we get a vertical asymptote. So I've drawn in my vertical asymptote. So I have a few details here. I want to find my min and max. So I've got my points of discontinuity are going to be on the vertical asymptote and the domain boundary. So those domain boundaries both give me actually discontinuities. One is a jump discontinuity, the other one is an asymptote. Okay, so let's find the derivative here. So we're going to differentiate this expression. So the derivative on the left, so I'm going to do this in green. My derivative here is going to be my rational function. So it's going to be 1 times x minus 1 divided by x minus 1 squared. Okay, oh, I need to use my quotient rule, sorry. So it's going to be minus x times the derivative of x minus 1, and then that's all over x minus 1 squared. So simplifying that expression, I get x minus x, so those x's cancel out. I end up with -1 on top, and x minus 1 squared on the bottom. Okay, so in the domain of less than -1 and greater than +1, I'm going to use that green function, and I know that at x equals 1, there is an undefined value here. Okay, so I have another boundary here, which I have to test. I have to check. So at -1, okay, it's undefined as well because that's an endpoint. And then I'm going to test my slopes through those points. So in this case here, y prime at -2, okay, because -2 is part of the green boundary, so the green domain. When I plug -2 in there, well, this slope is always negative, so it's always going to point down. Okay, same on the other side, y prime at +2, this is always negative, so it's going to point down like that. I need to then work out the derivative for the negative domain. So the y prime for the negative domain is going to be really the same thing. So if I factor the negative out, I'm basically going to get -1 over x minus 1 squared. That's the same, the square bracket represents the same derivative as the green. So this just becomes the same derivative, now it's positive. In fact, it's positive throughout. So if I plug in 0 into that, I'm going to end up with a positive slope through here. Okay, so it's going to slope positively towards the vertical asymptote. It's going to slope negatively away from the vertical asymptote. So that, in fact, is going to give us asymptote that is pointing the same direction on both sides. Okay, so I'm going to check for my endpoint behavior, so my horizontal asymptotes. Doing the horizontal asymptote, I'll do it in a different color here. So the limit as x approaches negative infinity for f of x, okay, we're going to use a green function for both. At negative infinity, we're going to end up with negative infinity over negative infinity, which is 1. So as I go to the left, I'm going to have a horizontal asymptote at 1. Okay, the limit as x approaches positive infinity of f of x, okay, in that case there, I'm going to have the same horizontal asymptote because I'm going to use a green function again, because on the right side of that of the graph, we're going to be using the positive domain, the green domain function, so that's also going to be equal to 1. So I'm going to have a horizontal asymptote at 1 as well. Now the difference is one is going to be going up to the purple line and on the other side is coming down.